In this video, we will practice solving trigonometric inequalities. This is AP Precalculus topic 3.10. If you appreciate the content, please give it a like. If you have not yet memorized these 9 trig facts, pause the video and memorize the chart right now. Number 6. What are all values of theta on the interval from 0 to 2 pi, for which 2 cosine theta minus 1 times 2 sine theta plus 1 is less than 0? For an inequality this complex, you want to solve it using a sign chart. Make sure you have 0 on one side like this, and then call the other side of the inequality f of theta, so we can refer back to it later. Now, ultimately we need to find where f of theta is less than 0. But we're going to begin by finding where f of theta is equal to 0. Since this is already factored, we can find the values of theta that will cause f of theta to equal 0 by setting each one of these factors equal to 0. So if I set 2 cosine theta minus 1 equal to 0 and solve, I'm going to add 1 to both sides and then divide by 2. So I end up with cosine theta is equal to positive 1/2. Setting 2 sine theta plus 1 equal to 0, I would subtract 1 and divide by 2. So I would get sine theta is equal to negative 1/2. Let's take these each one at a time. Back to cosine theta equals 1/2. I can find the reference angle involved here by asking myself the cosine of what angle is 1/2. We have memorized that the cosine of pi over 3 is 1/2. Therefore, pi over 3 is the reference angle. A reference angle is the angle between the terminal side and the x-axis. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 3. Since in this case we want cosine to equal positive 1/2, we will stick to the first quadrant and the fourth quadrant, where the x value, and thus the cosine, will be positive. The angle in the first quadrant, with a reference angle of pi over 3, is pi over 3 itself. We can think of 2 pi as 6 pi over 3. So this angle in the fourth quadrant must be 5 pi over 3. So far, we have found 2 values of theta where f is equal to 0. These will go on the sign chart later. We can find more values by finding where sine theta is equal to negative 1/2. Let's start with the reference angle, which we can find by asking the sine of what angle is 1/2. Ignore the negative sign for a second. We have memorized that the sine of pi over 6 is 1/2. Therefore, pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. In this case, we want sine to equal negative 1/2. So we will stick to quadrants 3 and 4, where the y value, and thus the sine function, is negative. We can think of pi as 6 pi over 6. So this angle in the third quadrant is 7 pi over 6. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant must be 11 pi over 6. We just found 2 additional values of theta at which f is equal to 0. Let's make a sign chart using these 4 critical values. Label your sign chart as f of theta and create a row for each one of your 2 factors. Notice that the domain is limited to the interval from 0 to 2 pi. So we need to put the domain limitations on the sign chart like this. 0 goes here and 2 pi goes here. We will now put these 4 critical values in order from least to greatest across the top. Focus on the first row, which goes with the factor 2 cosine theta minus 1. Let's highlight the critical values where this particular factor was equal to 0. Looking back, when we set 2 cosine theta minus 1 equal to 0, we got pi over 3 and 5 pi over 3. So this first factor is equal to 0 at pi over 3 and 5 pi over 3. It's helpful to highlight these two positions because these are the only two places where the first factor might change signs. Therefore, instead of having to check 5 different intervals, I really only have to check 3: left, middle, and right. Similarly, the factor of 2 sine theta plus 1 was equal to 0 at 7 pi over 6 and 11 pi over 6. So, this factor might change signs at 7 pi over 6 or 11 pi over 6. Again, instead of having to check 5 different intervals, I really only need to check 3: left, middle, and right. Back to the first row. It's time to determine whether 2 cosine theta minus 1 is positive or negative in each interval. In the first interval, we can use 0 as a test value, since this is not one of the places where this factor is equal to 0. It's not one of the critical values. So if I plug in 0 for cosine, cosine is the x value on the unit circle, and right at 0, the x value is 1. So this is really 2 times 1 minus 1. 2 minus 1 is positive 1, so this factor is positive in this interval. Let's skip to the last interval because we can use 2 pi as a test value, and 2 pi is in the exact same position as 0 on the unit circle. So plugging in 2 pi will give you the same result as we got from plugging in 0. So this factor is positive in this interval. That's here and here. So we just need to check the middle interval now. And we can use 7 pi over 6 as a test value. There's nothing wrong with using 7 pi over 6 as a test value. However, there's a better option. So look at the unit circle. Between pi over 3 and 5 pi over 3, we're talking about the interval from here and all the way around and back to here. We can pick any test value we want on this interval. Cosine is the x value on the unit circle. So a great test value to pick would be pi over 2 because the x value here is 0. So in my mind, I am thinking about pi over 2. So if we plug in pi over 2, the cosine will be 0. 2 times 0 is 0. That leaves us with the negative 1. So that tells us that this factor will be negative in this interval. What about the factor of 2 sine theta plus 1? For the first interval, we can use 0 as a test value. So if we plug in 0 right here, sine of 0 is 0. So that wipes out this term, leaving behind a positive 1. So this factor is positive in this interval. Let's skip ahead to the last interval because again we could use 2 pi as a test value, which will have the same result as plugging in 0. So I know this factor will be also positive in this interval. That leaves us to check the interval between 7 pi over 6 and 11 pi over 6. I could use 5 pi over 3, but let's think if there's a better option. The interval between 7 pi over 6 and 11 pi over 6 is right here. So a great value to use would be 3 pi over 2 right here. So as I'm checking this interval, I'm using 3 pi over 2 as a test value. Sine is the y value on the unit circle, and right here the y value is negative 1. So if I plug in 3 pi over 2, I get negative 1. 2 times negative 1 is negative 2, plus 1 is negative 1. So this factor is negative in this interval. Now let's record the overall sign of f of theta in each of these 5 intervals. A positive times a positive is positive. So that'll be positive here and here. A negative times a positive is a negative, so these two intervals will have f of theta being negative. A negative times a negative is a positive, so f of theta will be positive right here. I am about to highlight the solution set across the top of the number line. However, first I like to consider whether these four critical values, where f of theta is equal to 0, should be included in the solution set. In this case, no. We are looking for where f of theta is less than 0, not equal to 0. So, these four values where f of theta is equal to 0 should not be included in the solution set. What about the points at the beginning and end of the domain? Should they be included? Well, first of all, 0 and 2 pi are included in the domain. We have 0 is less than or equal to theta, and theta is less than or equal to 2 pi. The or equal to part means that these endpoints are included. So it's just a matter of whether f of theta is less than 0 at 0 and 2 pi. And in this case, it's not. See the positive in this interval? That includes this endpoint. So f of theta is positive, meaning greater than 0 at 0 and 2 pi. So we don't want that. We don't want greater than 0. We want less than 0. So even the endpoints of the domain will not be included this time. If this had been greater than 0, then these 2 points would be included. So since we are looking for where f of theta is less than 0, the solutions will be between pi over 3 and 7 pi over 6. Okay, f of theta is negative here, thus less than 0. And also between 5 pi over 3 and 11 pi over 6. Here's the final answer in interval notation and written as an inequality. Number 7. What are all values of theta on the interval from 0 to 2 pi for which sine theta times 2 cosine theta minus radical 2 is greater than or equal to 0? Let's name this f of theta. To find where f of theta is greater than or equal to 0, we begin by finding where f of theta is equal to 0. And since this is already written in factored form, we can find where f of theta is equal to 0 by setting sine theta equal to 0 and solving, and by setting 2 cosine theta minus radical 2 equal to 0 and solving. For that second one, I'm going to do part of this in my head. We would add radical 2 to both sides and then divide by 2. So that will give us cosine theta is equal to radical 2 over 2. For a moment, focus on the first one. We want to find the values of theta that will cause sine theta to equal 0. Sine is the y value on the unit circle, and y values are equal to 0 here and here. So that's at 0 radians and pi radians. But actually, I should include a third solution because 0 and 2 pi are both included in the domain. So the y values are equal to 0 here and here and here. That last one is 2 pi. So we have 3 solutions on the domain. We have theta is equal to 0, theta is equal to pi, and theta is equal to 2 pi. Now focus on the second equation. We can find the reference angle by asking the cosine of what angle is equal to radical 2 over 2. We have memorized that the cosine of pi over 4 is radical 2 over 2, so pi over 4 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 4. Since we want cosine to equal positive radical 2 over 2, we will stick to quadrants 1 and 4, where the x value, and thus the cosine, is positive. The angle in the first quadrant, with a reference angle of pi over 4, is pi over 4 itself. So that's our first solution to this little equation. Theta equals pi over 4. We can think of 2 pi as 8 pi over 4. So this angle in the fourth quadrant must be 7 pi over 4. So that's another place where f of theta will equal 0. Let's use these 5 critical values to make a sign chart. Your sign chart should be set up like this, with a row for each factor, the critical values across the top, and make sure the sign chart is labeled as f of theta. Let's start by highlighting the critical values at which sine theta is equal to 0. Looking back at our work, sine theta was equal to 0 at 0, pi, and 2 pi. So I'm going to put a little highlight here, here, and here. These are the only places where sine theta might change signs. So I really only have to check 2 intervals, left and right. These orange highlights also remind me that I won't be able to use 0 and 2 pi as test values in this row. Now let's look and see where 2 cosine theta minus radical 2 is equal to 0. Well, here's the work for that right here. That was at pi over 4 and 7 pi over 4. So I'm going to highlight those 2 values, which means I have 3 intervals to check, left, middle, and right. Also, because 0 and 2 pi are not highlighted, I know that I can use 0 and 2 pi as test values if I'd like. Let's go back and decide whether sine theta is positive or negative in each one of these 2 intervals. So in the interval from 0 to pi, okay, which remember that goes from here all the way to here. I can use any value I want in this interval. The easiest one to use would be pi over 2 right here at the top. Sine is the y value, and the y value at pi over 2 is 1. So this factor is positive in this interval. On the interval from pi to 2 pi, I can use 3 pi over 2. The y value here, and thus the sign, is negative 1. Emphasis on the negative. So sine theta is negative in this interval. What about 2 cosine theta minus radical 2? In this first interval, I can use 0 as a test value. So plugging in 0 right here, the cosine of 0, well, remember, cosine is the x value on the unit circle, and at 0, the x value is 1, because we are 1 to the right. So plugging in 0, the cosine of 0 is 1, so that's 2 minus radical 2. Radical 2 is smaller than 2 itself, so this will be a positive number. Plugging in 0 and plugging in 2 pi will always give you the same answer, because we're talking about the same position on the unit circle. So I don't need to think through it again. I will automatically put a positive here since I had a positive here. Now we just need to check this middle interval. Between pi over 4 and 7 pi over 4, okay, that's from here all the way around to here. So I can use any angle I want from here to here. An easy one to use would be pi over 2, because, again, cosine is the x value on the unit circle, and right here at pi over 2, the x value is 0. So, so in my mind, I'm thinking pi over 2 right now, where the cosine will be 0. 2 times 0 is 0, so that's gone, leaving negative radical 2. So that tells me that this factor will be negative in this interval. What about the overall sign of f of theta? A positive times a positive is a positive. A positive times a negative is a negative. A negative times a negative is a positive. And a negative times a positive is a negative. So I'm about to sketch the solution set across the number line on the top. However, I need to start by considering whether the critical values, shown here in blue, will be included in the solution set. At these 5 critical values, f of theta is equal to 0. Should those be included? Well, in this case, yes. F of theta is to be greater than or equal to 0. So I'm going to show that we are including these 5 values in the solution set because all 5 of these are values where f of theta is equal to 0. Remember how we put these little orange marks here? Each of these was one of the solutions that made f of theta equal 0. So they're all included, so closed circles. In addition to that, we are looking for where f of theta is greater than 0. So the additional solutions will be in the intervals where f of theta is positive. So that's going to be between here and here, and between here and here. So I am about to write the solution set in interval notation. But be careful, and because a common mistake is that students will leave out this single solution over here, the 2 pi. That's one of the reasons why I'm trying to get into the habit of marking the endpoints first as included or not included, because that way I won't forget. I see this dot sitting here and I won't leave it out. So I encourage you to do the same. Here is the solution set in interval notation. We use brackets instead of parentheses to show that the endpoints are included, and we include the single value of 2 pi inside of a pair of braces. Here is the same solution set written as an inequality. In this form, we use the or equal to line to show that the endpoints are included. Number 8, what are all values of theta on the interval from 0 to 2 pi for which cosine squared theta minus cosine theta is less than 0? Let's define f of theta as equal to the left side of this inequality. However, let's go ahead and factor it. I'm noticing a common factor of cosine theta, so let's pull that outside of the parentheses. It is the GCF. That will leave cosine theta minus 1 inside the parentheses. Eventually, we want to know where f of theta is less than 0, but first we find where f of theta is equal to 0. We can find that by setting each factor equal to 0. So we have cosine theta is equal to 0, and adding 1 to both sides, we have cosine theta is equal to 1. Cosine is the x value on the unit circle, and x values are equal to 0 here and here. So cosine theta, and thus f of theta, will equal 0 at pi over 2 and 3 pi over 2. Where does cosine theta equal 1? The x value is equal to 1 right here, to the right by 1. So that is at theta equals 0. Well, that will also be at theta is equal to 2 pi. Because if I go all the way around and back, I end up at that same spot where the x value is 1. So we have to record both of these as solutions because both values are included in the domain. So theta equals 0 and theta is equal to 2 pi. Let's use these 4 critical values to make a sign chart. Your sign chart should be set up like this, with a row for each factor and the 4 critical values across the top. Don't forget to label your sign chart as f of theta. I like to highlight where each factor is equal to 0. So let's look back. Cosine theta is equal to 0 at pi over 2 and 3 pi over 2. So let's highlight pi over 2 and 3 pi over 2 in the first row. Cosine theta minus 1 is equal to 0 at 0 and 2 pi. So let's highlight here and here. Now let's decide whether cosine theta is positive or negative in each interval. What about the interval from 0 to pi over 2? That's from here to here. Well, cosine is the x value on the unit circle, and in this interval, the x values are positive. We are to the right of the y-axis. So cosine will be positive in this interval. Let's go ahead and look at the last interval between 3 pi over 2 and 2 pi. That will be from here to here. The x values are also positive in this interval, still to the right. Now let's consider the interval from pi over 2 to 3 pi over 2. That's this interval right here. Clearly, the x values are negative on this interval. We are to the left of the y-axis, so cosine will be negative in this interval. Now let's decide if cosine theta minus 1 is positive or negative in this interval. Notice that it's only one interval that we need to check, from 0 to 2 pi. We put orange marks here to remind us that these are the only two places where cosine theta minus 1 is equal to 0. So these are the only places where cosine theta minus 1 might have changed signs. There will be no sign changes on the interval from 0 to 2 pi. It'll either be plus 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 or minus minus minus. So we really can pick any test value except for 0 or 2 pi. Let's use pi over 2 as a test value. Cosine is the x value on the unit circle, and at pi over 2 the x value is 0. So the cosine of pi over 2 is 0, leaving the negative 1. So that means cosine theta minus 1 will be negative throughout this entire interval. What about the overall sign of f of theta? A positive times a negative is a negative times a negative is a positive, and a positive times a negative is a negative. It's time to graph the solution set on the number line across the top. I like to begin with these critical values that cause f of theta to equal 0. Should these points be included in the solution set or not? Well, we are looking for where f of theta is less than 0, not equal to 0. So we should not include any of these critical values that cause f of theta to equal 0. So I will indicate that these points are not included using open circles. Since we are looking for where f of theta is less than 0, the solutions will be in these intervals where f of theta is negative. So from 0 to pi over 2, and from 3 pi over 2 to 2 pi. Here's the solution set written in interval notation, and here it is again as an inequality. Notice that we use parentheses to show that the endpoints are not included in interval notation, and as an inequality we write less than instead of less than or equal to show that the endpoints are not included. Number 9. What are all values of theta on the interval from 0 to 2 pi for which 2 sine squared theta minus sine theta is greater than 0? Let's call the left side of the inequality f of theta. As we record f of theta, let's go ahead and factor out the common factor of sine theta. So there will be a sine theta out in the front, and then if we divide by sine theta, the first term inside the parentheses will be 2 sine theta. The sine theta cancels out one of the sine thetas. And for the last term, sine theta divided by sine theta is 1. So this is what goes inside the parentheses. Instead of making this greater than 0, we need to begin by finding where f of theta is equal to 0. In factored form, we can do this by first finding where sine theta is equal to 0. We're taking each one of these factors and setting them equal to 0. If I set the second factor equal to 0, I'm going to end up adding 1 and then dividing by 2. So we need to find where sine theta is equal to 1/2. back to sine theta equals 0. Where will this happen? We know that sine is the y value on the unit circle, and y values are equal to 0 here at 0 radians. All right, look at the endpoint, the y value is 0. But then the y value will be back to 0 again here at pi. Actually, I'm noticing that 2 pi is included in the domain. So if I go all the way back to the beginning and back to here, this is a third place where the y values are equal to 0. So sine theta, and thus f of theta, will equal 0 at the critical values of 0, pi, and 2 pi. Where will sine theta equal 1/2? We can find the reference angle by asking ourselves the sine of what angle is 1/2. We have memorized that the sine of pi over 6 is 1/2. So pi over 6 is the reference angle. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we want sine to equal positive 1/2, we will stick to the first quadrant and the second quadrant, where the y value, and thus the sine function, will be positive. The angle in the first quadrant with a reference angle of pi over 6 is pi over 6 itself. So sine theta will equal 1/2 at pi over 6. We can think of pi as 6 pi over 6. So this angle in the second quadrant is 5 pi over 6. These are the 5 critical values at which f of theta will equal 0. Let's use these to make a sign chart. To make the sign chart, we need a row for each one of these factors. Label the sign chart as f of theta, and put your 5 critical values where f of theta equals 0 in order from least to greatest across the top. In this case, the endpoints of the domain happen to be critical values. If they weren't, we would still include them at the beginning and end of the sign chart. We need to decide whether sine theta is positive or negative in each interval. However, let's start by indicating the critical values where sine theta is equal to 0. Sine theta is equal to 0 at 0, pi, and 2 pi. So let's highlight those values in the first row. 0, pi, and 2 pi. These are the only places where sine theta might change signs, so we really only have to check 2 intervals, not 4. We need to check the interval from 0 to pi, and then the interval from pi to 2 pi. So, in the interval from 0 to pi, well, I started to talk in terms of test values, but that would be silly. We know that sine is the y value on the unit circle. And on the interval from 0 to pi, we are above the y-axis. So, of course, the y values are positive in this interval. So, sine will be positive between 0 and pi. Similarly, on the interval between pi and 2 pi, all right, that would be like this, these y values are below the x-axis. These are negative y values. So, sine theta will be negative in this interval. What about the factor of 2 sine theta minus 1? Let us again highlight the values where this factor is equal to 0. That was at pi over 6 and 5 pi over 6. So this factor will equal 0 here and here. So we have 3 intervals to check and not 4. Also, notice that 0 and 2 pi are not critical values of this factor. We did not highlight them. 2 sine theta minus 1 is not equal to 0 at these values. That means that we can use them as test values. So plugging in 0 right here, the sine of 0 is 0. So this is gone, leaving the negative 1. So this factor is negative in this interval. Let's jump over to the last interval because we can use 2 pi as a test value, and 2 pi works the same as 0. All right, the sine of 2 pi is also 0, so again we get negative 1. So this factor is negative throughout this interval. Consider the interval from pi over 6 to 5 pi over 6. That's from here to here. A good value to use would be pi over 2. The y value at pi over 2 is 1. So we would have 2 times 1 minus 1. That is positive 2. So this factor is positive in this interval. Let's consider whether the overall sign of f of theta is positive or negative in each interval. A positive times a negative is a negative. A positive times a positive is a positive. Positive times a negative is a negative. And a negative times a negative is a positive. Now it's time to graph the solution set on the number line across the top. I like to begin by deciding whether the critical values should be included in the solution. Remember, at these 5 values, f of theta is equal to 0. Should they be included in the solution? We are looking for where f of theta is greater than, but not equal to 0. So these 5 values should not be included, and we will indicate that using open circles. Since we are looking for where f of theta is greater than 0, the solutions will be in the intervals where f of theta is positive. That's from pi over 6 to 5 pi over 6, and from pi to 2 pi. Here's your solution in interval notation, and here it is again as an inequality. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.